Hello and welcome. In this lecture we will discuss a few basic but very important statistical definitions. Later in the course we will use those terms when we describe data quality of Earth observations or reliability of models and predictions. But let's start with a very familiar term, the mean value. The mean, or better arithmetic mean, is often also called average. This value is calculated in a very simple way. All we need to do is to calculate the sum of values that belong to a certain property and then divide it by the number of how many values we added. Let's consider a simple example and assume that we measured temperature 5 times and got the following results. First, if we compute the sum of these values, we will get 78. If we divide this now by the number of values, which is 5, we get 15.6 degrees Celsius as an average or mean value for our measurements. But what's the meaning of this value? Well, considering certain mathematical assumptions, one could say that the arithmetic mean is the most likely value for a certain property. In this case, we measured only 5 times, but many sensors take a lot more data, and averaging is really useful to reduce the amount of data and get a single representative value for the whole group of observations. But we can do more. We can also compute a statistical value called standard deviation. The standard deviation shows how much our values differ from the mean. As differences can be either positive or negative, one takes the square of these differences, then sums up everything and divides it by the number of values minus 1 and takes the square root. The reason why we need to subtract 1 here in the denominator is beyond the scope of this course. However, when we are dealing with a large number of measurements, for example several thousand of temperature readings, it normally matters less if we subtract 1 or not. But let's calculate the standard deviation of our temperature measurements. I'm going to skip the units, but please remember that our measurements were made in degrees Celsius. First, we subtract the mean from each value, square this difference, and sum it up. If we do this, we get 3.2. We divide this by 4, which is the number of observations minus 1, and get 0.8. In the last step, we take the square root from that and get 0.89 degrees Celsius as standard deviation from our measurements. Very often, the standard deviation is taken as an indicator for uncertainty of our mean value. So coming back to our 5 values, we could write the mean together with the standard deviation in order to indicate how reliable a value is. A small standard deviation expresses that all our measurements are very close to each other, saying that the mean value is quite reliable. On the other hand, as we just have seen in this example, one measurement was 17 degrees, which is 1.4 degrees larger than the mean. Therefore, it is not a surprise that our calculated mean comes with quite a large uncertainty. Talking of standard deviation and uncertainty directly leads over to 2 very important terms which we often use when we talk about data quality and observations. These terms are called precision and accuracy. The easiest way to memorize those 2 terms is when you think of shooting on a target. Accuracy states how close your shots are to the center of the target. Precision, on the other hand, states how close together your shots are. So high precision and high accuracy means that all your shots are inside or close to the bullseye. However, your bow could be slightly misadjusted, and even though you try to aim at the center, all your shots land together but far away from the bullseye. So you see, standard deviation or uncertainty refers to the term precision, as it just describes how close our data or measurements agree with each other. Giving a value for accuracy is more complicated, in particular when it comes to earth sciences. Often we don't know the true or correct value. But how can we then say how much our measurements are off? Well, one idea is to carry out two totally different measurement types or use different instruments and then see how well the two groups of observation agree with each other. The drawback is that we need to assume that at least one instrument is measuring the true value. Another method is called calibration. Here we carry out measurements under ideal or controllable conditions so that we can really assess the accuracy of a certain sensor. After this calibration has been performed, we take the sensor out to the field, assuming it is still accurate, which means that it measures the true value rather than having a so-called bias. A bias is another important term, and it can be understood from this image as well. The upper right figure is a good example that shows what a bias is. All shots are wrong by the same distance and direction. We can say that this shift is a bias. In general, biases are very hard to detect unless instruments and sensors are calibrated. For ground-based instruments, this can usually be done anytime, but imagine satellites. There is no way to calibrate a sensor once the satellite has been put into orbit. Therefore, it is very important that spaceborne instruments are calibrated before they are launched into space, or that there is equipment on board which can do the calibration. So, mean, standard deviation, accuracy, precision, and many other terms were mentioned here. Please try to remember those, as they will be used in later lectures. In case you're not sure about the meaning of one of those, maybe you want to come back to this video. Thanks for watching and see you next time.